All right, welcome everybody to another product spotlight. And man, do we have an awesome show for you today. Net zero retrofits are rare. Over 100 countries representing more than half of the world economy have already committed to net zero emissions by the year 2050. Tens of millions of existing buildings must be retrofit to net zero. Now, hydronic shell technology offers an HVAC solution leveraging advances in design and construction technology to reduce costs and shorten construction schedules. How can we do this and minimize disruption of the occupants living and working inside existing buildings? But let's not stop there. We're also going to talk today how this can be used in new construction, modular, panelized. This is a new technology that nobody has seen that I know of yet. So by integrating external components such as photovoltaic panels, shading devices, and lighting, can this system transform individual buildings and entire neighborhoods? Let's learn how hydronic shell retrofits can result in dramatic energy savings and carbon emission reductions, provide superior indoor air quality, thermal comfort, and acoustics. So right after we thank our sponsors, we're going to bring David Goldstein in, who is the founder and CEO of Hydronic Shell. But first, I want to thank Forward Solutions Group, Ben Hershey, Joe Butler. They are a team with more than 175 years of experience developing and specifying manufacturing for panelized and volumetric industries. With best practices in development and implementation, they offer consulting with investors, developers, manufacturers, and builders in using offsite manufacturing methods. Forward Solutions is driving companies to succeed where others have failed. So please, if you have any questions, reach out to Ben at forwardsolutionsgroup.com. I know they can help. And also a big thank you to Howick. Howick is a pioneer in the technology of precision light steel roll forming machines. For over 40 years, their commitment to innovation in cold form steel, also known as light gauge steel, precision manufacturing, uncompromising quality, and exemplary customer service have defined the Howick way. Their commitment underpins the competitive advantage enjoyed by their customers. To learn more, please visit their website at howickltd.com. All right, with that said, it is time to jump into this show. I know David is waiting in the wind back there, anxious to come on and share their new and exciting technology. David, welcome to the show.
Hi, Dave. Thanks for having me.
Yeah, thanks for being on the show. So hydronic technologies and coming up with a way to retrofit existing buildings and use this on new buildings is going to be a very, very interesting conversation. So before we hop into that, David, we ask everybody on this show, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or Jennifer on our team will call your mother and we'll bring her on the show to get the real deal. So go ahead. You got 2 minutes to do it, Dave, and then we're going to jump into this conversation and your presentation.
All right. Well, I'll do my best. So I was born and raised in Queens, New York, and that's where I stayed until I went off to college in New Hampshire, where I studied mechanical engineering. And after that, I started working. For a couple of years, I was working briefly in Chicago and spent a little bit of time working in Europe, and ultimately decided that I wanted to be in New York. Basically, I love New York. I'm from New York. That's where I wanted to live and work. So I did move back to New York, and the first thing I did was search for mechanical engineering jobs in New York. And what came up? Well, it was HVAC, 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 HVAC. So I said, okay, I don't really know much about HVAC, or I don't know anything about HVAC, but apparently if I want to be a mechanical engineer in New York, that's what I need to learn. So that's what I did. I started my first job as an HVAC engineer, and honestly, kind of fell in love with it immediately. I loved the fact that it was really important from an energy perspective, because that was something that was on a lot of people's radars at the time. So that was important to me. But also, I just loved the fact that there was so much to learn about HVAC, but also just the construction industry in general. I knew that I could learn as much as I possibly could every single day, and I would never run out of things to learn. So I knew that this would be a good industry for me. And then, so I did that for about 14 years. And then my life changed about a year and a half ago when I started this new venture. And here I am on the Dave Cooper Live Show.
Here you are for sure. I mean, this is cool stuff. So we've been talking for a while, and this is really a concept that you have designed and engineered with your partner. So why don't you give a shout out to your partner and talk a little bit about that real quick?
Yes, my partner Lindsay Dubosar, she's awesome. Unfortunately, she couldn't join us today. Maybe we'll do a follow-up show sometime or something, and you guys will get to meet her. But uh, she's trained as an architect, but she's really focused her career on design technology, and that's something she's been doing for about 15 years. And so I'm sure we'll get more into it, but design technology is a huge part of what we're doing, and I know a huge part of what you talk about on your shows and what your audience is interested in, and so that's a huge part of our whole business. And so
Right.
yeah, I could talk a little bit about that stuff, but sometime we'll need we'll need Lindsay to get on and tell us more.
Yeah, for sure. Well, and I think it's great, and I wish Lindsay was here. It's always wonderful when we have more women in our space that are doing things, and she's putting a lot of effort and time into this. So it's important that we let the world know that you do have a partner in this. All right, so the concept of what you're doing. Why don't you tell us a little bit about this concept and why you're thinking differently about it, and what made you think differently about it, right? Is it because it's not just for retrofits? I mean, it's harder to do a retrofit than new construction, but there's just a big focus on how do we take these existing infrastructure around the world and improve them to net zero and provide better occupancy for better health, better air, better quality of living. Walk us through the thought process and how you came up with this design, and then we'll hop into the presentation a little bit later into the show.
Sure. So, I mean, you did a really great job setting it up in the intro. I mean, basically, I'm sure everyone has heard of net zero by 2050 as, a goal, a target, around the world. That's kind of where people have decided we need to get to. Um, but what that means for buildings, for the construction industry, um, is a huge challenge, actually. And to be honest, I'm not sure the industry has totally wrapped its head around what a challenge this is. And
Okay.
there's two main aspects of that. One is just how huge the need is. I mean, we basically, in order to hit that target, we're going to need to retrofit roughly 3% of our building stock every year. So that's 3% doesn't sound like a lot, but that's a lot. That's millions of buildings every year that need to be retrofit. And not just, minor retrofit, but, serious deep energy retrofits to really bring energy consumption down. So this is just the scale of this challenge is huge. The other thing
Right.
that I think is underappreciated is just how hard it is to do these retrofits. I think when people, just think about it, kind of on the surface, they think, oh yeah, install some heat pumps, improve insulation. Yeah, we could do this. But it turns out when you actually look at actually doing it, it's really, really hard. And the way I came to realize that was I was actually working on a pilot project for an affordable housing building here in New York, just what should have been a relatively simple pilot project to install some mini split heat pumps in a few apartments.
Right.
And it became really clear that the hardest part about this is going to be the fact that we need to do these retrofits on buildings with tenants in the building. We can't kick people out to do this kind of work. So we have to do these major upgrades with tenants in the building, and we have to coordinate around those tenants. We have to minimize disruption to those tenants. It's kind of workable if you're talking about like a single family home or like 2 or 3 units. But when you're talking about large multifamily buildings with, hundreds of
Right.
units, how do you coordinate that kind of effort? Uh, Basically it's practically impossible, and that's what we found on this pilot project. Even running one simple refrigerant pipe down a wall, if it's an empty building, it's super easy, but if you're doing that in someone's occupied apartment, just that simple
Right.
thing
Right.
becomes really, really hard. So that's what got me thinking that this is going to be a real challenge that our industry I don't think is ready for. And basically the type of solution that we need to address this needs to have a few components to it. So one is that I feel we need to do these retrofits completely from the exterior, because that's basically how we avoid this problem of how to not disrupt the tenants. Is we need a solution that can be installed completely from the exterior without actually going into the building to do the work. Another thing we need is we need it to be economically actually attractive. We can't have this proposition where building owners are going to pay a lot of money to do these retrofits, and then all they get at the end of the day is their carbon emissions are lower. That's not going to be a compelling case that can be scaled. The other aspect of it is, because the scale is so big, is we really need to take an industrialized approach to this. It can't be, separate little design teams working independently on each building with a different solution for every building, because it's just not going to scale, like I said, to millions of buildings a year if that's the approach we take. So we really, and I know this is, a lot of what you
Right.
talk about on your show, it's about industrialized construction, prefabrication, modular, a lot of those things that people are starting to do well for new construction, but take some of those same principles and see how can we apply it to retrofits. And
Well, and that's it, right? So,
mhm,
and this is going to get really interesting to have this conversation, because your system is a modular system. It is like an external skin that'll go on the exterior of a building, or it
mhm,
could be an external skin on a newly created building to achieve the same functionality. So, with
mhm.
that, I'm looking forward to getting into this presentation. How do you put a retrofit on the exterior of a building and not actually have to go inside the occupant's space whatsoever? I mean, there has to be some inside work to get like the air flowing in there, no?
Right. Well, that's a good question, and I mean, that's the trick. The hard part is to figure out how do we do that. And actually, on a conceptual level, it's actually not that difficult once you really think about it. So in terms of so there's two main things we need to do for these kind of retrofits. We need to insulate the buildings really well. And basically, to me, we should be insulating these buildings to passive house kind of standards. Bring those loads way down.
Yeah.
And that obviously we can do from the exterior. We can insulate buildings from the exterior. The HVAC part is what's been more complicated. Like, how do we actually do that in a way that's non-invasive? But if you think about it, if we need to, basically, we need to electrify the heating systems in these buildings that are burning
Right.
fossil fuels. So we need a new way to heat these buildings. So if we're wrapping this building in this super insulated shell, all we have to do is make that shell itself heat up, and that heat will radiate right into the building. And it's actually a really kind of simple, straightforward, and effective way to heat the building, especially because the buildings that need this the most are the buildings without insulation or poorly
Right.
insulated buildings. So that heat is just going to radiate right in, and it's actually going to be super comfortable. Nice radiant walls radiating a gentle heat into your building, super quiet. There's a lot of advantages to doing it that way. It
So it's like an
it gets
electric blanket for your building.
exactly. That's actually the way I first thought of it when I first had the idea. Was I thought about
Mhm.
when I used to visit my grandma, and she used to have this electric heated blanket, which I had never seen before, and I just thought that was so cool. And that was literally the thought that came into my head, like the moment that I had the idea for this.
Right.
Um, the cooling is a little bit more complicated, because when you super insulate a building, you can bring the heating loads way down to almost nothing. But for cooling, you still have your internal gains. Being super insulated is not going to totally bring your cooling loads all the way down. So you do need
Hmm.
more capacity for cooling. It's hard to do that just with radiant. So we did need to figure
Right.
out a way to get some extra capacity out of the system, which I'll get more into. And then, we need to supply the air as well, like you said. But we can run, we're mainly focused on multifamily buildings, and multifamily buildings don't need a ton of ventilation air. They're not like,
Okay.
office buildings or other kind of buildings. They actually need a pretty small amount of ventilation air. So we can actually fit the ductwork to carry that ventilation air. We can use slim, like pancake flat kind of skinny ductwork, run that within the shell to get the ventilation air to all of the apartments.
Got it. Got it. Got it. So, I mean, this panel system, so it's on the exterior of a building, let's say an existing building, and how does it attach? Do you have to remove any cladding from an exterior building if it's a brick building? How does it attach? And then where are the mechanical systems that would feed this system And then we'll get into some other obvious questions like footprint. How does it increase that? Is there issues with that? Things of that nature.
Yeah. So more great points. So the structural, part of it, and disclaimer, I'm not a structural engineer, although my brother is, so I've been getting free consulting from him. But the structural, that's one of those things that is going to vary from building to building, and that's one of the hardest
Yep.
parts about retrofits is every building is different. We can't just generalize and say this is how we're going to do every building. The structural attachment is one area where that's going to depend on the building.
Okay.
Ideally, if we can attach right into the existing brick, if it can support it, then that's pretty straightforward. Or if there's an
Hmm.
exposed slab edge that we can attach right into, then that's pretty straightforward. But there will be scenarios, I'm sure, where we need to remove some of whatever that exterior cladding is to get to the structure that's behind it and attach to
Right.
that. And part of this is making this external shell as light as we can, because obviously we don't want to cause issues with the weight of this thing, and the existing structure not being able to support it. But um, basically, this is something that's done. People have done overclad retrofits, especially
Right.
in Europe. They do a lot more of it, and they've solved the structural issues, and they can make it work. So we think we'll be able to make it work as well.
Perfect. Perfect. So, all right, listen, everybody. We are live on LinkedIn, YouTube, Facebook, and Twitch. Why are we live on Twitch there, David?
'Cause that's what the kids watch.
That's what the young people watch. The next generation, not only watch, they're playing games there, virtual reality, augmented reality, and all of those things. So hit that like and share button right now. And if you are not subscribed to our YouTube channel, we are being watched over 100,000 minutes. That's how they tell it to you. I know it sounds better in hours, right? 100,000 minutes, though, is a lot of minutes every 28 days, and we are growing super fast. And we will be releasing a new video from Boxable today on the Casita. We did an entire review of a new Boxable house that was designed and built by Casita. So join us for that. Jennifer and I will release that today. All right, David, let's hop into it. Let's get into the presentation and let's start showing what this system is all about so people can visually understand it. Go ahead.
Let's do it. So yeah, this is going to be a short presentation, but it's hard to really explain what it is without showing it. So hopefully these slides will help to show how this system works. Basically, the image you see here is an existing building, right? Say this is an existing building we need to do this kind of deep energy retrofit to. So the way we're going to approach this is, one, we're going to install that new HVAC system, right? This high performance, super efficient, all electric HVAC system. And to get back to a question you asked before that I didn't answer, is about the new equipment. So that equipment is going to go up on the roof, right? So we're going to have this central equipment up on the roof, and we're going to distribute the air and the water piping to risers that are going to be running around the perimeter of the building, basically
Wow.
running up and down between the windows. And then that's the HVAC part of it. But then, of course, all of that is being enclosed in this super insulated shell. So it's basically all that HVAC is being integrated into that shell.
So is the HVAC system, is all that put on first and then the shell goes over top of it, or is it already integrated into the shell, all the connection points?
So I think there could be various ways to approach it, and I'm not sure that we've fully figured out, how we'd prefer to do it, because there could be different ways. But I think what would make the most sense probably is you basically install this HVAC that you see here first, or at least start to install it first. Uh, and you start to install, I mean, I'll get more into how it works, and you also start to install the panels that are going between those risers. So that once you install the panel, now you have the risers are already there. You can make your quick connections to those risers, and you're basically done with those connections. But I actually have another slide coming up that shows a little bit more of what that sequence could look like.
Okay.
So now that's what's happening on the exterior of the building. But to zoom in to an apartment level view to see how we're actually bringing that conditioning into the apartment. So what we're looking at now is basically a section of the existing apartment, right? So what we want to do is first we're going to remove that old inefficient window. And by the way, if there's a radiator there, or if they have a through the wall AC unit or a window AC or whatever, all that can go away because they're going to have totally new HVAC when we're done with this. And so what we
Oh,
then
cool.
do after we remove that window is we install this new panel on the exterior. So it's that super insulated panel with the integrated window. This is all coming prefabricated uh, from offsite, and we install that panel over the existing facade. And basically, we're leaving a cavity between the new panel and the existing facade, and it's within this narrow cavity, say roughly 8 inches, that we're running all of this HVAC, the ductwork, and the piping. And so basically, the way this will work, what you see here is we run hot water through this radiator element that's in that cavity, and what that does
Yeah.
is it heats up the air in the cavity. So now the entire cavity that's around that shell is now warm, so that that heat can then radiate into the apartment. But then we also have this component here, which is basically a custom fan coil unit that we designed that will also fit within that narrow cavity. And that's going to do two things for us. One, it's going to give us additional capacity in case we can't get the full capacity from the radiating through the wall.
Right.
And it's also where we're going to introduce the ventilation air. So this is where the ventilation air is now being supplied into the apartment. And I mentioned
Wow.
it works for cooling as well, and it really is in cooling that we really need that supplemental capacity from the fan coil unit, because we're not going to get that totally by radiating it through. So
Right.
that's the main area where that fan coil unit comes into play.
Very cool. So as you're putting on the new skin of this, and you're coming up to an apartment, you're pulling out the existing window, and you're
Mhm.
putting in a nicer, more insulated window, and then really you just have whatever snaps in place to clean it up and move on to the next window above it or to the side of it. Is that
Right,
kind of what you're
right.
thinking?
Yeah. So let
Yep.
me show that in a little more detail. So this is
There it
basically
is.
what that panel looks like. So this is that
Okay.
prefabricated panel.
Yep.
Basically, the facade part of that panel can be any kind of existing facade technologies that are out there. Other facade panel manufacturers that are already making these kind of facade products. It can be that same product essentially, but then all we do is we integrate our HVAC components into it. So it's basically that radiator piping that is
Okay.
heating up the cavity. It's that slim fan coil unit that we call the hydro box that I mentioned, and it's that fresh air
Mhm.
duct that's coming in to deliver, to basically mix the fresh air into the air that the hydro box is circulating. So that's what we're installing over the existing facade. And this is just an image of how these panels go over the windows, and how you have those risers between each of the windows, alternating between duct risers and pipe risers, so that each panel has the quick pipe connections on one side and has the quick duct connection on the other side. And if we have perimeter bathrooms or kitchens, then we can use that riser for exhaust, basically, uh, instead of having ventilation air, and all the risers will also have exhaust at the perimeter. If the bathrooms and kitchens are not at the perimeter, if they're interior, then that building will already have some sort of exhaust system, because you need to have one if you don't have perimeter windows. And so we would basically tap into that existing exhaust system at the roof. And basically the idea is we're taking that exhaust and running it through energy recovery, so that when we condition the fresh air, we're not consuming as much energy.
Sure.
So
And it's putting that air barrier between the two structures as well. So you're not really trapping any humidity or moisture within the building the way this system is going to work, correct?
yes, so good point. So the idea is this new facade is a complete air, water, vapor, thermal barrier. It's basically giving us everything we need, in terms
Uh-huh.
of protecting us from the outdoors. So everything in board of that is essentially now interior space. And the other, detail that it's worth mentioning is this ventilation air duct that's bringing fresh air to the hydro box.
Yeah.
It's going to have a small tap on it that's going to supply a small amount of air into that cavity. And that's going to do two things. It's going to pressurize the cavity slightly, so that, to prevent the infiltration of outdoor
Hmm.
air into the cavity. But it's also, that ventilation air is fully conditioned, dehumidified ventilation air. So if you do, for whatever reason, get any moisture, in this cavity, if somehow it sneaks in there, whatever way, we are continually drying out that cavity. So that's how we keep it dry,
That.
and, not to have any moisture issues. So back to, the discussion about the sequence, it starts again, back to technology, and using technology to make the whole process as efficient as possible. So you start with your existing building, you do a detailed laser scan of the building, maybe using drones or whatever it is. Take that information, that digital information, move it into the design environment, do your design, take that digital design, move it to fabrication, fabricate your panels,
Right.
and then you take those panels, you install them over each of the windows, and you also install those risers between the panels. And now you see in this image here, basically we have stub out connections from those panels, so that what can next be done pretty easily is just making those connections from the panel to the riser. We're talking about small pipes. These are going to be like 3/4 inch copper pipes that we need to connect. And this duct is going to be like a 6 inch by 4 inch duct. These are going to be small connections that we need to make. Now we make
Right.
those connections. We need to then do our quality control, basically do our testing, our balancing, our commissioning. We basically want to make sure everything's working properly before we cover it all up, because that's the last step, is to put those final panels over the risers, and now basically we're done and our building is totally enclosed.
And the occupants up to this point, outside of their window being pulled and a new one put in, haven't been disrupted at all.
Exactly. So someone at some point after you install the new panel, well, so first that you remove the window, and then after you install the panel, someone needs to come in and basically finish around that opening. So, someone has to come in and, sheetrock that up and do that finishing, which, yeah, they do have to go in the apartment, but in terms of how invasive it is, it's pretty minimal. You don't need tenants to move their furniture out of the way, or, you're not going to be in there for days. You basically just have to come in, quickly finish around that and get out, and you're done.
Right. Right.
And then the last piece of it is the equipment on the roof. So this is, this is a central HVAC system with central air handling equipment and central heat pump that's basically, supplying all the air and the water that's being circulated throughout the shell. And the good thing is, kind of like I was mentioning before, if we super insulate this building, the loads come way down. So this heat pump actually doesn't need to be too big. Even if it's a big building, the amount of capacity you're actually going to need per apartment,
Right.
especially when you take diversity into account, it's going to be a relatively small heat pump. So it makes this whole thing quite manageable. And these types of rooftop units and these air to water heat pumps, these are readily available on the market. There's no, we're not like reinventing anything with this kind of equipment. This is off the shelf, standard equipment that can be used to supply this system.
Yep. And what about climate? This works in any climate?
Yeah, so the climate, that's another interesting aspect of this. Certainly it works in any climate. There's no reason it wouldn't work in one climate or another. it
Yep.
The benefits are the most obvious when we're talking about cold climates, with
Mhm.
that buildings that have very high heating loads, uh, buildings that are mostly relying on fossil fuel boilers, to meet those heating loads. Those are the buildings that are going to see, the most dramatic, improvement by going to this system. It certainly applies, to warm climates as well, but warm climates aren't quite as challenging as cold climates when it comes to heating with heat pumps, essentially.
So, just trying to think this through. Like when we think about the practical application of this and what others are doing, I mean, is this the first of this type of thought process that you've seen out there, David, or is there anybody that's been doing something similar?
Well, on a detailed level, I haven't seen anyone doing something
Yeah.
similar, but kind of at a high level, at a conceptual level, lots of people are talking about things like this, in the sense that people realize that, certainly from an insulation perspective,
Right.
it needs to be done on the exterior. And a lot of people are talking about prefabricated, insulated panels getting installed on the exterior. And people do recognize that the HVAC side of it is a big challenge. And people do talk about, somehow integrating the HVAC into the exterior as well. So on a
Sure.
conceptual level, people are having that discussion, but I'm not aware of anyone else who's, kind of worked out the details of how to do it, without having any HVAC components in the building. So just for
Right.
example, people and people have done examples of doing like mini split kind of systems or VRF systems where you run the refrigerant piping out the exterior and then pop into the
Right.
apartment. But in that scenario, you're still popping into the apartment. You still need to, mount a unit in the apartment on the wall somewhere. You have to run your refrigerant piping to it. You're going to have condensate. You need to take that condensate, run the piping somewhere, find, a place to dispose it. So some of this stuff is happening on the exterior, but there's still work that has to happen inside. So as far as I know, this is the only approach where it's completely from the outside. The HVAC doesn't have any components that actually need to go into the building.
That have to go into the building because it all gets pumped from the window. Now, let's say you have a multi-unit apartment, that's pretty deep into the building. I mean, how much air can you actually move and pump into a building of, is there a certain size limits that this works on, or how does it work?
Well, I would say the vast majority of multifamily buildings
Yep.
are not particularly deep, and that's by design. That's essentially a code requirement, in most cases that I'm aware of, that any living space has to be near a window, has to have light and air essentially from a window. So
Yeah.
it's not like an office building where you have like a 40-foot deep floor plate and, you somehow need to get conditioning all the way, 40 feet into the building. You know, I'm certainly here in New York, most residential multifamily buildings are already being conditioned exclusively from the perimeter. There'll be like
Yep.
maybe some radiators at the perimeter, and for cooling, they have maybe a through the wall or through the window unit, but it's already, all happening from the perimeter. And because those floor plates aren't deep, it works well enough.
All right, so I'm gonna put it out there. I mean, I see people are joining. So if you're just joining us, Andrew Wilkinson, you're a little late today, I see, but he apologized. We're talking about hydronic shell technology, where we are talking about designing a mechanical system to retrofit existing buildings so we can bring them up to the net zero code that's coming. And this is a problem not only here in the United States, but globally. But on top of that, my mind is working, David. I mean, I could see this being used in an offsite manufacturing facility to where your system is the external cladding with these multifamily buildings, especially now that we are seeing a lot of modular hotels out there, modular multifamily buildings that are using the traditional PPAC or units, the window units for heating and cooling.
Yep.
I could see this actually being integrated and being used in a facility like that as well. Thoughts on that?
Yep, I totally agree. Basically, everything I just described, it would work the same exact way for new construction. The only difference is instead of putting it over an existing wall, instead there is no wall there yet. You just have your structure and you're attaching that panel to your new structure. But
Yeah.
when you really dig into it, a lot of the challenges that will come up when dealing with existing buildings, like you mentioned earlier, the structural challenge of how do you attach it? What if the existing structure is in poor condition or something? Pretty much all of those problems go away when you start thinking about this for new construction. So I do think there's a huge opportunity there. And another challenge our industry has besides carbon emissions is affordable housing. And a lot of the time in affordable housing multifamily units, for cost reasons, uh,
Mm-hmm.
they're basically installing like through the wall units, or relying on window air conditioners or
Right.
something like that, because the cost aspect. But having this kind of approach where it's really a high performance central system that's going to have really great air quality, really great thermal comfort, really great control, but at the same time we can keep the costs down because we're doing it in a prefabricated modular way, taking advantage of all of those aspects of industrialized construction. So to
Right.
me it's a way to bring that high performance, but bring it in an affordable way to affordable housing, essentially. So I think there's really big opportunity there. Of course, it
I love
doesn't
it.
have to be affordable housing. Could be any kind of housing. That would work great for luxury housing too. But I think affordable housing is where really there would be
Right.
even more of a need, because let's be honest, the conditions of existing affordable housing buildings aren't great, and I think we need to really improve.
Well, I mean, that's it,
conditions.
right? I mean, just improving the air quality of some of these old buildings, which, people don't even know are making them sick, don't even know that the kids don't have allergies. It's just all the other crap that they're breathing from the old building inside. I mean, I think there's so many benefits to this, and there's so many upselling points to something like this design. So why don't we go to a couple comments that are out there, and we'll take some questions if there are any. Anthony Goudet in the house. What's up, Anthony? It's funny, Dave and I were talking about you before the show. David Goldstein is an excellent engineer, and this is a great and effective solution. So excited. Thanks, Anthony. Hope you are well. And hey, check out Anthony's show. He does a show every once in a while. All right, George Ryman. Wow, the building HVAC system and aesthetics can be upgraded all at the same time. That's a good point, George. It's not just the fresh air, but you're right. You can give a facelift to your building, and who knows, if it's not affordable, maybe you can increase your rent then. There's some value there.
That's a huge thing to point out. Just imagine, like I mentioned, I grew up in Queens and New York, and spent my life walking by these old brick buildings, these neighborhoods, and just imagine, like, we can totally revitalize the appearance of these buildings with modern, beautiful facades, and just such a huge opportunity to just change the look of our cities.
Right, and it's not a Band-Aid, it's actually providing a better solution, and that's the difference. Perfect. All right. Andrew Seeley from G-Pod in the house. I love this topic. Can't be overstated how important it is. Well done, David Goldstein. David, these are all some pretty significant people in the industry, so well done. Well done. Who else is out there? Rob Hoskin. What's happening, Rob? Glad to hear QC is included. Let's get a financial model to get this done. Talking to NY, New York CERTA about this yet. Rob's interested. Have you talked to the New York CERTA? What is NYSERDA, by the way?
New York State Energy Research and Development Authority, or something.
Yeah, he would know. Yeah,
something like that. But I mean, that's a great point. So the financial part of it is super important, because it's not going to be cheap to do this. The idea is you're going to get a lot back for the money you spend, but it's still not cheap to do. There is no such thing as a cheap net zero retrofit, unfortunately. If there were, people would already be doing it, and nobody's doing it, up to this point. So there is no cheap way to do it, but we do get those benefits and a lot of savings that come out of it. But getting the the financial side of it, how do you pay that upfront cost, and do it in a way where you can use your savings to cover the the financing cost? That's a huge part of it, and so I totally agree with that comment. And in terms of NYSERDA, I have spoken with several people at NYSERDA. NYSERDA is one of those groups that is really pushing this exterior, prefabricated panel retrofit solution. What I've found so far is that we're basically very early in development. We don't have an actual product yet that's ready to be installed on a building. We've been, kind of designing, this thing, and, working through that early stage of it. And so it seems to me like, to really get NYSERDA's attention, we need to actually have this thing physically built, where they can actually see it, and see that it works. So my engagement with them has been somewhat limited to this point, but they do have some opportunities out there, like the various funding for research and development. And so that's something I'm definitely keeping my eye on.
Perfect. Thanks for that question, Rob. Next question. Brett Little. What's happening, Brett? Is this air source or ground source, he's asking?
Good question. So I think the most straightforward way to do it is air source. The air source heat pumps, they're going to operate super efficiently. And one reason is because the loads are so low, and because we're radiating the heat in, we're actually going to generate very mild hot water temperatures. We're talking like 90, 95 degree water. So our air source heat pumps, even if it's 0 degrees outside, are going to be operating really efficiently, because of that lower hot water temperature we need to make. Obviously, geothermal is great, in terms of efficiency. You can get, a few extra efficiency points by doing geothermal. So I think it's totally possible to do. It's just, it depends on the cost benefit. I think my instinct is that in a lot of cases, probably wouldn't be as attractive just in terms of the economics to do it with geothermal, but it's certainly possible, and I think it needs to be evaluated on a case-by-case basis, and where it makes sense, no reason not to take that approach.
Awesome. Great. Thanks, Brett. Good to have you join us today. All right. Brett Little, some more. How about ventilation?
Yep. So ventilation is a key part of this. So I mean, you can see on my screen, I don't know if my screen is still up.
I'll put it back up right here.
Okay. So basically, we're installing packaged rooftop units that will be fully conditioning ventilation air. So we're talking about, tempering the air, also filtering the air and dehumidifying the air. Basically, having this fully conditioned ventilation air that's going to be distributed throughout the shell and to each of the apartments. And that unit is also taking exhaust from the kitchens and the bathrooms, running it through energy recovery before exhausting it, out of the unit. So yes, ventilation is a part of it. It's hugely important part of it, and that's one of the big benefits, like you were mentioning, Dave, is the poor indoor air quality in so many of these existing buildings and all the health issues that result from that. We can really take a big bite out of that and really help with that situation a lot, because we're going to be providing this nice 24/7 ventilation air to all the apartments.
Perfect. Brett, thanks for the question. All right, we got another one. Andrew Wilkinson, all the way from the UK in the house. 100% can be designed and integrated with all methods of construction. Absolutely, Andrew. This is big stuff.
Totally agree. Yep.
Andrew says he will be looking further into this with you. So I would expect to hear from Andrew Wilkinson. And I can tell you now, it's a good person to be heard from.
Awesome.
All right. So is Brett Little. So don't catch me wrong. Brett's got it going on, man, and especially in the net zero space. 100% the person to talk to. Buzz Howitzer in the house. Hey, Buzz, what is happening, man? Buzz, I saw a post with your Jeep or something just covered in mud, and you said your wife wasn't happy, but you had a good time. So good to see you, Buzz. All right, moving on. So let's talk a little bit further about this, David. Do we have more to go on this slide, or are we done with that?
No, I think we're basically done with the slide deck, unless some other question comes up that we need it for.
Sure, for sure. So I think we have one last question. Let's put it up there. Sorry, I got this beeping. Norm Sayre, how do each individual units control their temperature? Hey, that is by far an amazing question.
Yeah. Okay, well, let's bring the slide deck back up.
There you go.
Okay. So yeah, this is a really important aspect. If we're going to talk about thermal comfort, people need individual control. And basically what you see here, so I mentioned this is a fan coil unit that sits under the window, right, which is basically a fan and a coil. Typical fan coil unit, although there are some differences which probably don't have time to get into right now. But basically within this enclosure is a control valve. So
okay.
And this fan coil unit and the radiator piping are all in series. So we basically have one control valve that sits inside the unit, and that's going to control your total output to the apartment because it's controlling the radiator and the fan coil unit. And so every room will basically get individual control because they'll be able to open and close that control valve.
Wow. Norm, hopefully that answered your question. Thanks for tuning in today. I see as a fan. I wonder what Norm does. I'll have to look. Perfect. All right. So, David, listen, we are right at about 10 till the hour. So what are some key things that are super important that you want everybody to take away from this? And I'm going to start off with the first one. One, this is a concept, and you guys are eager to be able to put this into practicality somewhere. Is that accurate? So
correct.
Yep. So if you're out there, Brett, Andrew, and anybody else, here's a great opportunity to help somebody out, a young mind who has come up with a new idea and a new concept. So I'm just going to put that out there. Hopefully some of these folks that are watching can give you a hand with that.
Awesome.
So perfect. Now, what do you think is important? Because I probably just took the most important thing away.
Well, that's actually, building it is definitely important. And that's what we want to do is we're ready to build it. We're done designing. Right. We're done playing around on the computer. We're ready to build. But I guess the other important thing I just want to mention is just to like recognize what a huge opportunity this is. I think a lot of people see, these net zero carbon targets, as being, very restrictive and very hard to meet, and it's a huge challenge, and it is. But for our industry, it's a huge opportunity. I mean, this is going to be an enormous market, from a business perspective.
Right.
Like I mentioned earlier, millions of buildings need to get retrofit every year, and that's more than new buildings that are built. It's a huge, just the scope of it is huge. So there's
Yep.
for people who are bringing solutions, where solutions are badly needed, I think it's just a huge opportunity. And also there's the opportunity from the perspective of just making people's lives better. It's not just about reducing carbon emissions. It's all the things we've been talking about. It's improving indoor air quality. It's improving the aesthetic of the building. It's improving thermal comfort. It's just totally revitalizing our buildings and improving people's lives. I think is
Sure.
something to get really excited about, and it's there's a huge opportunity there as well, because a lot of
Right.
people live in buildings that are in very poor condition and they need something like this.
Yeah, for sure they do. For sure they do. I'm sure there's some ups and downs with this, right? Like zero lot coverage, buildings and things that you got to kind of figure out. What
Mhm.
is the overall thickness from the panel, from the interior to the exterior of the sheathing with that
Yeah.
airspace in it?
Yeah. So that's a good point. So this solution is not going to work for every single building. We're not saying that, every building is going to get a hydronic shell and it's going to be great. Every building is different. This is going to work for some buildings. It won't work for others.
Yep.
One building type it won't work for is any building where, for whatever reason, you cannot expand the volume of the building. Like you mentioned, if you're at a lot line, or if there's just some zoning requirement your building can't
Right.
expand, then this solution wouldn't work if you have that kind of restriction. But in terms of the depth, um, right now we're targeting 16 inches. It's basically 8 inches of your facade panel buildup, and then 8 inches of the cavity space that you're running all your ductwork and piping in. So a total of
Right.
16 inches. But I do think as we get deeper into it, and more refining from kind of a product design point of view, we can find ways to narrow that down. We're making these panels in a factory, factory technology. Uh, we can have tighter tolerances than you have when you're doing on-site construction. We can kind of
Yep.
integrate the mechanical components along with the facade in a way that I think we can squeeze that down. So, who knows, maybe we get it down to 12 inches, or, something like that. But that is, one of our goals, is to continue with the design and product development and see, just how much we can squeeze that dimension.
Sure. Sure. Anthony Goudet says you didn't say MITX. MITX? Didn't mention MITX.
Should I pretend I know what that is, or should I don't know what
I
MITEX
don't
is.
even know what it
Oh,
is.
okay.
But I was thinking maybe that's like engineer brain to engineer brain right there.
Oh yeah. So
Engineer.
yeah, well, that's a good point, Anthony. So we mentioned that our big thing we're trying to do now is actually build this. And so we are in an accelerator program right now called Clean Tech Open, which is going to be ending soon, and that's basically been helping us to figure out a lot of the, besides the HVAC design stuff and all that, but more from the business perspective of how to get kind of everything lined up so that we're ready to actually do this. And
Right.
after that program ends, soon we'll be starting another program, with this group called the Engine out of MIT. That it's similar kind of accelerator kind of program, that's going to help us make the connections we need to make, and all that sort of thing to actually get this thing going.
Perfect. Love it. Love it. All right. What do we have? Do we have any more comments here? One last one from Mr. Andrew Sealy. Zoning requirements that preclude retrofits like this need to expire.
Hmm.
I would imagine there's going to be some zoning requirements willing to change to reduce the load on their city's electrical and mechanical infrastructure. I'd have to imagine there's going to be some of that happens, which will allow you to do what you need to do.
Yep. And New York actually already started doing that. They've actually passed a zoning resolution that allows more space to grow a building
They
from the
did.
exterior, because they're not going to solve this problem if they don't allow, that sort of flexibility.
For it. Right, right. All right, well, cool, man. David, is there anything we didn't talk about that you want to leave us with? We are got 6 minutes to go, but I think we covered a lot of it here. One, you need a good project. Two, you need a manufacturer. And three, you need a buttload of money to save the world. I love it.
Yeah, and honestly, we're looking to grow our team. Right now it's just Lindsay and myself, but this is a really big, project we're taking on. This is something big we're trying to do, and there's no way we're going to do it ourselves. So we're looking to, build our team, bring on additional expertise that we need, like you said, form those partnerships with manufacturers and installers and all that sort of thing.
Yep.
Ultimately, the holy grail for this type of solution is for it to be a kind of turnkey solution where you go to one provider. That provider has the ability to do everything from beginning to end, give you your retrofit. Again, because to do this at scale that we need to do it, that's, I think, the type of approach that needs to be taken.
Yeah, I agree. I agree. All right, David, listen, thank you so much for joining us today on the show. If you are not following David Goldstein, you're wrong. Follow him. You got to be following him. Check out on LinkedIn and where else are you at, David? How do people get a hold of you?
LinkedIn is good. Email is good. I'm not sure if my email is up anywhere, but LinkedIn. Well,
we can put it. We can definitely put it up there.
I check it all the time. So.
Well, I'll tell you what. Go into the show afterwards.
Anyone who's interested.
Yeah, go into the show and put your email in the comments afterwards, David, and they can reach out to you. We typically don't put those things up there because, not everybody wants to give their email out to the world. You never know what's going to go on there. And everybody else, listen, join us Friday, BS Friday at 1 p.m. with Mark Bare Naked Willie. We are leaving Biloxi, and we will be in South Carolina for the BS Friday show. So you don't want to miss that. We got a lot of great events coming up. David, thank you so much for joining us. We'll look forward to having you and your partner on the next time. And I hope the next time we have you on, we're showcasing a project that you are doing.
I hope so. Thank you, Dave. It was a lot of fun.
Yeah, it was a lot of fun having you. All right, everybody, stay tuned. I will see you this Friday. David, don't go anywhere. Everybody else, enjoy the rest of your Wednesday afternoon. We'll see you next time.